Okay, so this is the second video. So I'm gonna just kind of abbreviate, look at your review as we do these, because I'm abbreviating my instructions. So basically on number 5, it says, find the domain of the following functions. So what I look for when it comes to domain are domain restrictions. And domain restrictions happen at this point in the year. We've seen two types of domain restrictions, fractions and radicals. So if we look at this, we see that it's quadratic. Quadratics look like this. And we know because there is no fraction and there's no square root, there would be no problems. So if there are no problems, the domain is all real numbers, negative infinity to infinity. So we look at part B. We don't need to know what the graph looks like. Let's just do it with restrictions. So you would say, okay, if I have a divide by anything with x in the denominator, I have to say, I'm going to factor my denominator. So make sure if it's a quadratic on the test right here, we factor it to find the restrictions, and then we would set each of our factors equal to 0. So x plus 2 cannot calculate to be 0, otherwise we're dividing by 0. So then we would subtract 2. So we know x cannot be negative 2, or else this is going to calculate on bottom to be 0. But then we also happen to see a square root, so we'll also say, okay, and also 3 minus x, what's under a square root, has to calculate to be greater than or equal to 0. Otherwise, it's going to be a negative under a square root, and a negative number under a square root is imaginary, which we're not going to have in domain. First thing, 3 minus x has to calculate to be greater than or equal to 0. Now remember, if it is linear, and it is, only if it's linear, if we're looking at an inequality, if it's linear, we can just solve for x. So if it wasn't linear, everyone, recall what you would do is you would draw on the side a graph, and you would look at the graph and see when it is above 0, from what x to what x is it literally, look, is it literally in all this stuff up here? When is it calculating to be above 0? So that's what you're going to look for. But when it's linear, you can just solve for x. So we would subtract 3. So we have negative x is greater than or equal to negative 3. We would divide by negative 1. Remembering that if we divide both sides of an inequality by a negative, we have to change our inequality sign. So this says x values below 3. Now we have to combine these. So we have to make sure if we're going from 3 to negative infinity, we make sure to jump over negative 2 because that's creating a problem in our denominator. We would say negative infinity up to negative 2. We're going to jump over negative 2. We'll go from negative 2 up to 3. And then 3 is included. See, equal to 0 is okay here. So we're including 3. Why do we put parentheses around negative 2? Because we're not including, we're saying not negative 2. So this is a really good example, this next one, of like when we have a square root where it isn't linear. So if we were to look at this one, we would say, okay, a square root has restrictions. So it would be the absolute value of 3x minus 1 has to calculate, that piece has to calculate to be greater than or equal to 0. Now, if you know how absolute values work, you know you can plug in any number, and whatever you get in here is going to calculate to be positive because absolute values will make it be positive. So that means we can plug in anything and it will be positive, which is greater than 0. So it's all real numbers, obviously, or negative infinity to infinity. But let's say you didn't catch that right off. Then remember, like I said, if it is not linear, you need to graph it and see what's happening. So let's say we didn't catch the thought process of, oh, absolute values will always be above 0. So a reminder, absolute values in general are sharp V's. So normally an absolute value with no shifts, just the absolute value of x, everyone, looks like this. So as you can see, isn't it always above 0 for all real numbers? All of our x's are calculating to have y values above 0. So it makes sense that it's all real numbers. But we have to just make sure, because this is shifted, and if we have the absolute value of x as our parent function, we would then look at the shift here to graph it. So recall, if your leading coefficient is a 3 and it's in the parentheses, this would be a horizontal shrink. It's opposite of what vertical does. A horizontal shrink of 1/3. So that means you'll take your x values and times them by 1/3. And then we're going right, but we have to be careful because before we do shifts left and right, we need to fix this 3. So pull it out. Don't pull it out of the absolute values, but pull it out of each term. So then that would be x minus 1/3. So it's going right 1/3. Just a reminder, shifts left and right, we like our leading coefficient to be +1. So we're going right 1/3, which also affects our x's. So we would add 1/3. Now, just a reminder, if I'm doing a rough sketch here, a horizontal shrink will just literally like on the horizon, shrink it down. So that's not going to affect your domain and range. It's just how fast it's going left and right. So that doesn't really matter. It's going left and right no matter what. But this does matter. So we're going, what the heck? Yeah, sorry. So I said right 3, like I said. This would be what we'd be doing to our x's. So think about it, it's shifting right 1/3 unit, and then it's just shrunk. So if it's horizontally shrunk, then it would just be more like this, sharper. And this is at 1/3 0, see right 1/3 0. So pushing it up, shrinking it horizontally would make it like, yeah, sharper. So if we look at this, as you can see, you can use the graph to answer this. You can say, when is this function above a height of 0? And as you can see, the entire time, from left to right, we are above a height of 0. So let's instead do one like we could. So that's why it's all real numbers. I didn't finish my thought. Let's say instead we had this, the square root of x squared minus x. And I said find the domain. Remember, you would say, okay, x squared minus x has to calculate to be greater than or equal to 0. Because it is non-linear, we can't just solve it. We would factor out an x. We would get our x minus 1. When is this greater than or equal to 0? Then you would draw yourself a sketch. This would be the best way to figure it out. You'd say, okay, we would find our zeros by factoring. My x-intercepts are 0 and 1. So I am crossing the x-axis at 0 and at 1. So I'm just going to write that in 0 and 1. And then really it's as easy as saying, I'll do a rough sketch. I see my leading coefficients positive. So it's a smiley face parabola. So that's a rough sketch. That's all I need. Where is this calculating to be above a height of 0? It says the quadratic has to be calculating to be greater than or equal to 0. So as you can see, this part right here is calculating to be above 0, and so is this part. So we answer, obviously, since it's domain, intervals for x. So we'd say negative infinity to 0. We're including 0 because zeros are included. And then we're also going to go from 1 to infinity. Hopefully that makes sense of what I'm saying with that. If not, come get help. All right, so the next one says evaluate at a value. So like I said, abbreviating the instructions here, everybody look at your own. So evaluate at the point indicated. So just be careful as you do this. We know we're substituting in negative any value. Just be careful with your parentheses. Really, I'm sure you all know how to calculate these. You just usually make errors, so just be careful. That would be 3 times positive 1. Looks like plus 4 plus 1. So that'd be 3 plus 4 plus 1, which is 8. So pretty easy. So once again, this would be 2 square roots of parentheses 4 plus 5. So that's 2 square roots of 9. That's 2 times the square root of 9, right? So there's no addition sign right here. It was multiplication. So that doesn't change. That would be 2 times 3, which is 6. All right, so then the next one would be this 2 times the square root of negative 6 plus 5. That'd be 2 square roots of negative 1. That's going to be imaginary, so we're going to say non-real. If you needed to calculate it all the way, which we're not doing, up to this point, we're not doing imaginaries. So we would just say this is a non-real one, so we're not going to calculate it. However, think about it, the square root of negative 1 is I, so technically that's 2I. But once again, look, you're saying 2I is non-real. All right, so with C, you have the absolute value of 2 times negative 2, like that, then minus parentheses negative 2. Notice I always use parentheses. I recommend it so that you don't make an error with just subtraction or something. So I have the absolute value of negative 4, and then it would be obviously plus 2, because when we minus a negative, it becomes positive. The absolute value of negative 4 calculates to be positive 4. So we have positive 4 plus 2, which is 6. Like I said, not that it's necessarily hard, just be careful, don't make small errors. And 8, it says compute. This is where a lot of people get it wrong. And so make sure you're studying these. So it says compute f of x plus h minus f of x and then divide it by h. So what people do is they overthink what this is saying. Break it down. This says take function f and plug in x plus h. So let's just do this for a to begin with. So if this, we're just doing it for a, we would say, okay, we're going to take function f, which is negative 12x plus 4, and it looks like the first thing they want us to plug in is x plus h. So this would be negative 12, and instead of an x, we're plugging in our x plus h, and then we still have plus 4. That was f of x plus h. We then have a minus sign. I'm going to do it in black, actually. We have a minus sign. So then I'm going to use parentheses. This says minus f of x. So that means minus the original f of x. So minus parentheses negative 12x plus 4. All right. And then that's all over h. So then from here, you have to simplify correctly. So from here, you would distribute. You would look and see, how can I simplify this? It looks like there's no power here, so that means I'll distribute negative 12. This would be negative 12x minus 12h plus 4. Then we're going to distribute our negative, so it looks like it's going to be plus 12x. And it looks like it's going to become minus 4. And that's all over h. So then I'm going to combine like terms in the top. So it looks like I would have negative 12h's, and it looks like everything else is canceling out all over h. And then that is negative 12. So very doable. Let's do another one. So let's do the next one, just because this is one that is a little bit more advanced and a lot more errors happen. Sorry, taking a second to erase. I thank you for your patience with me. Okay, so this says take function, same thing, take function f and plug in x plus h. So now we're doing this one right here. So that would be 2, and then instead of an x, it says plugging in x plus h. So that'd be 2x plus h squared, and then we would have a plus 5. Don't put x. We've got to replace all of our x's with what it's telling us to plug in, which is x plus h. So then this would be x plus h, like that. And then we would have a minus 3. And then we'd have a minus sign from right here once again. So then I'm going to do parentheses, and then it says minus the original f of x. So then we would do minus 2x squared plus 5x minus 3. And then that's all over h. And I'm not going to get tempted to divide out any h's or anything across addition signs, so be careful. So at this point, I've got to make sure to actually square this appropriately. Don't square square. We have a 2 times x plus h times x plus h. Then we have a, right here, look, distributing this. I have a plus 5x plus 5h. I still have a minus 3. I then have a minus 2x squared. I have a minus 5x. I have a plus 3. So still can't combine stuff, not quite yet. I need to make sure I multiply this out. So I'm going to distribute these two together first. That would be x squared plus xh plus xh plus h squared. So you know how to distribute, people. So then that's actually x squared plus 2xh plus h squared. And then the 2's in front, so we now got to distribute that through. So that would have been a 2x squared. Then it would have been a plus 4xh. Then it would have been a plus 2h squared. And then remember, I already distributed all my negatives. I was really careful to do that, so all of this stuff is still just the same. So we don't need to use parentheses since I've already been careful and distributed everything appropriately. So we have plus 5x plus 5h minus 3 minus 2x squared minus 5x plus 3. So then from there, you should be combining like terms. So let's be really careful here. We have a 2x squared and a minus 2x squared. Awesome. We have a 4xh. I don't see any other xh's, so we have a 4xh. Now remember, this is still just the top. Don't forget about the h, but we're not quite there yet. We have a 2h squared. I don't see any other h squared, so I better write plus 2h squared. I have a plus 5x. I have a minus 5x. I have a plus 5h. I don't see any other h's, so plus 5h. Then I have a minus 3 and a plus 3. Okay, awesome. Now all of that is divided by h. So now at this point, we would then go ahead and say, okay, all of these terms have an h, so I can divide everything by h as long as I do it to each piece. So if I divide this by h, that's 4x. If I divide this by h, it would be plus 2h. If I divide this by h, it would be plus 5. And then obviously it was over 1. We divided everything by h. So 1, boom, one of our h's divided out, and then that was gone. X. So hopefully everybody sees how we did that. So then that would have been your final simplified answer. So you got it. So same formula. I'm just going to stay down here because there's our last function. So this one's going to be a smidge harder because a lot of you are just not as good with just like division and common denominators and stuff, adding fractions. So this one will have a lot of really good elements you have to be careful with. You have to really know your algebra to get this next one, I think, right? So it says same thing. It's the same, equation. It says take function f, plug in x plus h, then subtract off your f of x, and then after that you'll divide by h. So we're going to take function f, which is 3 over x, and we're going to plug in x plus h. So it will look like that. We will then have minus, I'm going to use parentheses just to make sure, minus the original f of x. So minus 3 over x, and that's all over h. Okay, then from here, you don't want to have fractions and fractions being divided. You cannot fix the division until we only have one term up here. I mean, you can, it's just harder and easier to make errors. So what I recommend is first focusing on putting these two together. Now remember, to add fractions, you have to have a common denominator. Common denominators can only happen by using multiplication. So it would not be okay to add h. You can't do that. That's not mathematically the same value. We can only change to have common denominators by multiplying by 1. So if this has an x plus h, this one either has an x plus h or needs an x plus h. This one doesn't have an x plus h, so we need to choose to multiply by x plus h. But if you do it to the bottom, you've got to do it to the top, because then you're really just multiplying by 1 in value, that is. And then over here, we see it has an x. We need an x here, so we're going to times by x over x. The whole point of doing this is so that you can combine like terms in your numerator. So on top, everybody, recall, on top, I have a 3x. I have a minus sign. Better use parentheses. I then have a 3x and a 3h. So then on top, I have this 3x minus 3x. Minus, I almost messed up. I've got to distribute my negatives, so then minus 3h. So then that would be negative 3h, and that was just the top. That's all over the common denominator of x and x plus h. The point of getting a common denominator, like we did, is so we can combine like terms in the numerator and write it as one fraction. And then this is divided by h. It's always sad when people get this far and then miss the next step. Now, what the most common error is people will say, I need to flip and multiply, and they'll put the h up here over 1. Well, careful, because on bottom you had an h. Technically, I would write it with all the placeholders. So isn't this technically h divided by 1? Because h divided by 1 is still just h. That way, when you flip and multiply, you're not going to make the error of flipping it into the wrong position. So then these h's divide out since we're just dividing across multiplication signs, right? So multiplying, we said that, multiplication, multiplication, multiplication. So then my top would have been a -3, and on bottom I would have had an x and an x plus h. Then I always have people say, should I simplify this? And I'm like, wait, simplify? Question mark. And what they're meaning is, should I distribute this? But remember, distributing is not any more simplified than leaving it factored. So yes, you could distribute if you wanted to, but you have not actually simplified it at all. They're the same exact thing. Not one is better than the other. So in my opinion, why go to the extra work of distributing?